power's on it. Just check the power real quick. Yep.
Yep.
So, good.
Okay.
You should be recording.
Okay. We're all set? Okay. Cool. Can everybody hear me? Am I being broadcast, or I'm just being recorded? Okay,
yeah,
cool.
It's recording an MP3 and an MP4 of the video here.
Cool. Awesome. Yeah, well, nice to meet you all. My name's Corey Forsyth. I am natively from Utah, but I haven't lived here for a while. I live in New York now, but I happen to be here this week, and I saw Jameson's tweet, and so I responded about giving a talk. And I have been doing a lot of front-end JavaScript stuff lately in New York. I have a small consulting company. We do a lot of Ember. Has anybody used Ember? Aware of it? Yeah, so Ember is really, for their asynchronous code, you must use Angular. For their asynchronous code, they have recently switched a lot of components of their architecture into using promises, and specifically RSVP.JS, which is one of their implementations. So if you're not, is everyone familiar with promises? Has anyone used promises in their code before? Okay, so, all right. Yeah, the promise, promises A+ is the name for a spec that has been written to describe how promises are working. It's available at this website. This is the sort of really high-level description of what a promise is. The spec is actually really cool because it's a very detailed spec. If you, I would recommend checking it out sometime, especially if you have trouble sleeping. But they also have an executable test suite that they give you. So for other people who are creating libraries that implement this promise pattern, they can actually run it against the test suite to see if it matches. Sort of it's a fairly complicated thing to get your head around. So having that test suite should hopefully make it so that different implementations converge and can be swapped out and behave the same way. And so, yeah, this is sort of in general, what it looks like when you're using a promise is you have a promise is something, so the bottom line here is actually where we create the promise, do something async, returns a promise object, and a promise object has a then method that you can call on it there, and you give it two optional arguments, a success handler and a rejection handler. And then you continue executing your code, and then at some later time, either your success handler or your rejection handler will be called based on what happened in the promise. Here's a more simple explanation of what promises are. They're just a way for sort of coordinating asynchronous activity throughout your code. They're good for handling general asynchronous stuff, and also where they become really powerful is when you combine them to do asynchronous things in order. So you have to wait for something to end before you begin the next thing, and then you continue in that chain. Other patterns for dealing with asynchronicity are generally callback-based code. Looks something like this, where you call a function and you give it two arguments. You give it at least one argument, which is a function that's going to be called at some later date. So in that way, it's sort of superficially pretty similar to promises. And then another one is evented code, where here we're creating a function that you're going to be called on success and one that will be called on failure. And then we do some JavaScript and add listeners for the different failure and success events, and we call those things back later. So separating the code from its eventual resolution of whatever asynchronous activity is happening. Let's see here. So one of the cool things about promises in particular, as opposed to those other two patterns, is that you see this a lot in nested callback-based code, is you have your code, every time you have a callback, if you want things to be ordered, you're going to have to, you have a callback, and then you have a callback to the callback, and then a callback to the callback, and so on. This is the same example I showed before with callbacks. The promise version is going to look very similar. So you can see there's almost no difference actually there. It's the same thing, except in this case we're getting a promise and calling then and giving it our success and failure handlers. So why use it if we actually end up writing more code this way? Because when we have something like this, like a really nested callback-based thing, this is pseudocode that I wrote, connecting to a database. When that connection comes back, doing something with it. getting a result, changing the result, saving it, and all these things need to happen in order. You can't do one until the other is finished. And you've got separate error handlers for each one, so you have this like code that keeps going towards the right side of the screen. And with promises, because they will chain the resolution from one promise to another, which I'll get into in a little bit, you end up with really nice flat code. You never go more than one level indented out to the right. So you keep, and these things are going to be guaranteed to happen in the same order that they are listed here on the screen. Yeah, so that's just the same code as before. Okay. Another thing is that with promises, you can you get to couple the code from its eventual result. So I'll show you an example here. This is actually like a slightly changed example from an app I was working with, a client app I was working with last week. There was this app that had an init function. I saw the init getting called, and I could tell that the app continued starting up, but I had no idea. I could see them right next to each other. I had no idea how we were getting to start. And I ended up having to like dive through a bunch of files, and what I saw was something sort of like this. There's the init, the start, and then like many lines later, and in fact, in the project I was working on, it was like spread over multiple other files. There were a bunch of things that had to happen, and then eventually they called back into the start method. You can see it right there at the bottom. And so this is, I would say this is like sort of like a complicated pattern, especially if you're coming into code where you don't know exactly how it works already. You have to sort of understand the whole path through the code before you realize that init and start just happen sequentially. And yeah, so here's what it would look like with a promise. You see your init method, it loads data, and then it calls start with that data. And so you don't have to really worry about how load data works, or even like when it calls back, to have like a good initial high-level understanding of the path through your code. Yeah, and then this is an example of using a promise. I'll get a little more into specifically how promises are created and passed around. Anybody have any questions about this or following? All right. Cool. So another thing that is really cool about promises is that they have very simple error handling. So if you have, here's some notes from the spec. But basically, when you call .then on a promise, you sort of enter this promise chain, and you can continue to call .then at each spot, like after each one returns, and they will essentially, you're going to propagate rejection handlers. So a rejection handler, like here where it says unrejected, it's optional when you call .then. So if you don't give one, then the rejection will just drop through to the next .then, and then continuing on. So if you, like commonly when you're doing a lot of asynchronous stuff, you are mostly concerned with whether it fails at some point in the chain, not specifically where it fails. So you can have a lot of, this is another way. So yeah, the rejection will just fall through until you actually decide you want to handle the error, and it won't get swallowed up in between, and you won't have to handle it specifically at each spot in your asynchronous code, like we saw earlier in the callback-based code. So it looks sort of something like this.
So you don't have to rethrow it, just load it.
Exactly. Yeah. It will keep going. So like here we've got a bunch of asynchronous lines of code happening through promises, and at the third one there we throw an error, so we raise an exception, and it will skip the next one, which is a fulfillment, like a success handler, and continue down until it finds any .then, which has a rejection handler.
Can you do any rewinding, retries, any level of flow control?
Oh, that's a good question. I don't think so. You would have to, like, these errors are going to come out of your success handlers typically. So
Can you say if this, go this path versus that path?
what you would do probably is in your success handler you would have a try catch, and you could deal with the error there instead of, if it gets thrown out of your success handler, then it will fall to the next rejection handler.
That being the next step for this,
Yeah, there's a way to rethrow it, and that's something that's not part of the promises spec, but it's something that RSVP.JS gives you, so you'll hit it in a rejection handler and then drop down to the next one also. But aside from that, I don't know if there's too much like good branching available. Let's see. So, oh, I think this is the same slide. It's the same slide. OK. Cool. Oh, yeah. So RSVP.JS is one of many implementations of promises, and they were written by the guys who are doing Ember.js too. So it's the library of choice in Ember, and it is the one I use. But they all do the same. Yes, exactly. Yeah, yeah. But it's got a couple extra niceties that are not part of the spec, like .fail. .fail is just an alias for .then with an undefined success or a null success handler and then an error handler. So you can add, it makes reading your code very easy because you can just do a bunch of async stuff and then at the end you do .fail. And I find it very pleasing to sort of read that .then, .fail. It's really clear how that's going to be handled. And then here's rethrow. So if you, normally if you are in a rejection handler from your promise, and at that point is basically where the chain stops. Nothing beyond that is going to be executed if you have a bunch of extra .thens after. But if you want it to, this is, primarily you would use this for debugging. So yeah, this code here is not going to get executed. You can call RSVP.rethrow with the error, and then it will just drop down to the next rejection handler. And sometimes that can be helpful for debugging if you're having trouble figuring out at which spot things are dying or whether they're making it through. Yeah, cool. So if you want to use promises, you can include RSVP.JS or any promise implementation in your code. And sort of I have found it a hard thing to wrap my head around originally how exactly specifically you use it. But as a rule of thumb, anywhere you would be passing a callback, instead you would call the success handler for your promise, or anywhere you would be triggering an event that would be success, you would call the success handler for your promise. And yeah.
So a way of having a trace as things go through, so you figure out the ordering of a specific event, that happens to be, when this order's thrown, then I have to deal with this problem because it's causing this unexpected
right.
feature.
If you have a chain of promises for a chain of synchronous activity or asynchronous things, you can add a rejection handler at any spot, and that will be invoked if the thing.
It's not built in the framework, but you can.
Yeah, yeah,
apply.
yes. I think they're doing some work on trying to make traces easier, but in general with this stuff, traces actually are pretty tough to use. Well, you end up with a lot of anonymous sort of functions and stuff like that. So, and so yeah, here would be an example. So here's an example of some async code. Our async is our function. We give it a callback, and then at some time later we call that callback, and that's what it looks like. And so to turn that into promise-based code, you would do something like this. Instead of taking any argument to async with promise here, you would immediately return a new promise, and this is the sort of the signature for a promise. So you call new RSVP.promise, and then you give it an argument, which is a function, and that function has two arguments, which are each functions, resolve and reject. And you just need to keep basically a reference to each of those functions, and you call whichever one is appropriate whenever this asynchronous activity happens to end or is finished and stuff like that. And the value that you give it will be passed into your success or failure handler. So yeah, that's sort of the way you would do a little simple callback-based thing. And then the nice thing is on top of this, you can just continue chaining, and they will just work going one after the other. Any questions about that part?
So that allows you to time things out cleanly if it's taking too long?
That's a very good point. It's hard to there's no concept of an actual timeout. This is just an example using set timeout. Yeah, yeah. No, I don't think there's any way actually to specifically expire a timeout, a promise. Yeah, it's gonna just hang until. It would be the same thing if you never triggered an onload on some evented API or something like that. It would just not do anything. Yeah.
Could you have some default set timeout that would just call the reject handler, and then if you didn't call the resolve handler as soon
Yeah.
Is there any problem if you call both the handlers? Will that blow stuff up?
I don't think so. I think it would end up being like a no-op.
Or just do whichever one is called first?
Whichever one is called first. Yeah, the spec is really clear that you can only transition out of the pending state into either resolved or rejected, and you can only do it once.
Okay.
I don't know if it raises an error if you would try to do it the other time. I don't think it would. I think it would just take the value of whatever called first. Yeah?
I was just curious, Jameson, will these slides be available on the website?
Sure. Yeah. Yeah, they're online already. I'll like send a link or something afterwards. Yeah, sure. Okay. So one important thing about promises is that you have to continue to return. If you want them to actually be chained in the proper order, you have to continue to return a promise from inside the success handler. Basically, this async with promise value becomes the argument that goes into this function. And so this then's success handler will not be called until this promise is resolved, if that makes sense. That's the way that the ordering happens. It's okay to return non-promise-based values from within like a success handler, but they'll just immediately fall through to the next success handler.
Is the output of one become the input for the next chain?
Exactly, yeah.
So could you do anything clever where if I return a closure that would be effectively the next chain in the link?
Yes, yeah, that's sort of how.
Reject chains then effectively on the fly as the promises are transformed. That's cool.
Yeah, I think so. Yeah, it takes the value. So if the return value of this success handler, this is the success handler, is a promise, then it will basically turn that. It will wait on that promise until the next one, so you can continue. Yeah. Oh, here's just an example of how you can sort of mix and match, like doing synchronous stuff in between your asynchronous stuff. And these values, the non-promised returns, will basically just cause the next success handler to immediately invoke. They won't wait until the resolution.
Does every promise have to be async? You have synchronous promises as well.
You could have a synchronous promise too. Yeah. The promises. What? Yeah. Actually. Right. Yeah, it's actually. I think it's actually the specification says that it must happen in the next turn, like the next frame of JavaScript. So you couldn't. Yeah, yeah. You could return the successful resolution immediately, but it would wait a tick, I think, to move on to the next one. Yeah. All right. And okay, this is a little bit. So this is sort of what I was saying before. Is the values. The thing that I haven't been showing up until now is that you pass basically the output of the last one feeds into the input of the next one. And so it sort of works like this. I think I have a really ugly picture. Yes. Shows something that I made with Sketch.
It's so clear.
Yeah. Yeah, that might be one to pour over on your own on a slide. Basically, like you call resolve and you give it a value, and that becomes your success value, or you call reject and you give it a reason, and that becomes your error reason. And then these things keep propagating through if they are called.
So just to make sure I'm clear,
Yeah.
You can return a promise from one of these chain handlers,
Mhm.
and then the argument that gets passed into the next handler is the resolved value of that promise, right? You don't have to worry about it.
Right.
The async anymore.
Yep.
Magically there.
Yeah, exactly. It will happen in order. Yes, yeah. And if it's like I said, if it's not a promise happening in there, it'll just pass that value on to the next one in the chain. So you can sort of mix and match them. Okay. Yeah, and so the sort of like the motivation I had for really looking into this stuff was I was working with a friend building an API that ended up using a lot of both callback-based and evented code, and we've been doing all this stuff in Ember, and we really wanted to like see them as promises, and originally we were having to mix and match callbacks and events all over the place, and so we sort of have been working on this wrapper called RSVP tools that allows you to just basically like wrap up any callback-based or evented API into a promise-based one. And so I didn't really have time to go too deeply into exactly how it works, but yeah, I would recommend if anyone is interested in this and wants to try to like turn an API that they already have to work with into promise-based. It's very simple to do. You basically just wrap something up in a promise, and where you would call the callback, you call the resolution instead. But this is a nice little API we made for doing that. So, yeah, thank you very much. Thanks for having me. Yeah.
There's a couple minutes for questions.
Sure. Yeah.
I have a question. I've mostly been working in Angular, so I'm more familiar with Q than RSVP. I'm just curious
Okay.
if you know much of how the different libraries relate to each other.
Yeah, that's a good question. Q is the only other promise implementation that I really know of, except jQuery sort of has it, but I know that people sort of scoff at the jQuery implementation. I'm not sure why. I don't remember exactly what is broken about it. I just know that it like badly breaks some of the spec tests.
They do weird things with error handling.
Yeah.
Errors don't propagate.
Is that maybe? Yeah, it must be something like that. Yeah. Yeah, exactly. Yeah. But I think Q and RSVP.JS in theory should be like swappable. I'm not sure what the state is of them both passing the specs.
I'm familiar with Angular. I use Q. If I'm familiar with Ember, I use RSVP.
Yeah, and you can, like in your own third-party code, you could just use whichever one you like. Yeah, they should have. They have the same base level API. .then with 2 arguments.
You're familiar from using Q.
Yeah, yeah, it would work exactly the same way.
Got a lot of extra nice stuff.
Yeah, RSVP has a lot of. It's super simple, super minimal. Yeah. Oh, okay. Yeah. Yeah. There's a bunch of other things RSVP has, which like collecting a bunch of promises, and it will wait. You can pass in a bunch of promises as an argument and wait for them and stuff like that. So yeah, so this is up at bit.ly. All the slides are up there if anyone wants to check them out. Any other questions?
Are you hiring?
We sort of are. Yeah, I have a small 2-person consulting company in New York. Yeah, we're definitely looking for people who are interested specifically in working with Ember, but like sort of like front-end stuff. Yeah, sorry. Yeah. Mm-hmm.
You guys work with Ember.
Yeah.
Do you know the status on Ember Data?
Ember Data.
2.0?
Well, they had the reboot, the J.J. Abrams branch, that actually sort of badly broke a few things. Like it is very rocky. I wouldn't recommend using it unless you are like going to be comfortable diving into the code. But this is their full-time focus now, Ember Data. So I think eventually it will get to like a stable state. Ember took them a long time, but they did get there. So I think they'll do it with Ember Data. Yeah.